Hello and welcome to another one of DJDD videos. Today we're going to look at some more advanced examples of naming compounds. So here we have polyatomic ion and a metal here, so it's definitely an ionic compound. We do not need any prefixes once we know it's ionic. Going a little faster, you should be pretty familiar with these rules by now. So the first element's normal, and the second polyatomic ion is just named, so this would be sulfite, because this is the lower number of oxygens in this oxo anion. And as a result, you get lithium sulfite. Don't need to worry about the 2 because it's ionic. All right, let's warm you up a little bit. Now let's look at this next one here. This one's a little bit more complicated. Reason being that we have a transition metal that's multivalent. All right, so what we need to do is first determine we've got the metal and the non-metal. Copper is a transition metal. Oxygen's a non-metal. Metal, non-metal is ionic compound again. We don't need any prefixes. First element is a transition metal. Copper can either be 1 or 2. So again, we have to work backwards. In the intermediate video, we did it with iron sulfate, I believe it was. We're gonna have to do it again with this one. So oxygen has a -2 charge, and since there's no 2 under the copper, that means it had to cancel, right? There should be a 2 here when it transfers its electron, so there had to have been another 2 here to cancel with the 2 that should have been here. So the way we work with that is we have unknown charge for copper, -2 is oxygen. They had to come down and cancel, right? These 2's had to cancel to give us CuO. The 2 was down here, but it disappeared. So the only way that occurred is if copper also had a +2 charge right there. So as a result, we can say this compound is copper 2 oxide. Copper 2 oxide. All right, this final one here. Again, metal and a non-metal. Manganese is right there, transition metal. And we've dealt with oxygen several times. Non-metal. And as a result, we know we have an ionic compound. No prefixes are needed. Manganese can either be 2, 3, or 4. So because the first element is a transition metal, we have to determine by working backwards again to figure out which one it is, 2, 3, or 4. Again, the process is the same. Oxygen has a -2 charge or oxidation number. And since there's no 2 down here when it transferred, that means it had to cancel. But this one's a little different because there's a 2 left over in the other element. They didn't both cancel like this one. So that means that in order for that to occur, Mn had to have the +4, so that when you divided both of the 2's, oxygen's left with a 2 subscript. Let's see that in action. So we have an unknown charge for manganese, -2 for that. And if we bring down the 2 here, it would be Mn2. Okay, and the only way to have a 2 left over when we divide both of these subscripts by 2 is if the oxygen subscript was a 4. So we had to go backwards with it, and if we go backwards with it, then we know that that manganese is a +4 charge. As a result, we get manganese 4 oxide. Manganese 4 oxide. So I hope you're getting familiar with the stock system. Practice, practice, practice makes perfect as always. The more you do, the more second nature this will become. Make sure you check out the series that goes the other way, from nomenclature to the compound formula. I hope I've helped. Thanks for watching. Have a great day.